All right, hello everyone, this is El Profe Lo. In this video, we're going to be talking about plotting vectors. We'll also be talking about vector addition, vector magnitudes, and vector directional angles. So I'm going to have a focus on working around with these vectors to make sure that you understand the variety of ways that this can be done. Okay, so we're given our vectors u and v. Okay, and remember that this could be written as the component forms and the vector notation. Okay, and really the conventionality of these notations are simply based on typesetting things and personal preferences when these were first being developed. Okay, so you could do the things with boldface, or my preference is to use the little arrow symbols, but I want you to be familiar with both. Okay, so if I want to plot vector u, vector v, right, and then the vector u plus v and the vector u minus 2v, here's what we could do. All right, so let's start with this point. All right, let's say we have a point somewhere in a coordinate space, and u is going to move 3 in the x direction, 5 in the y direction. So I'll go 1, 2, 3, 1, 2, 3, 4, 5. Right, so that movement of 3 and 5 is going to be vector u. Okay, and let's say that I had another point just somewhere out in space. Let's have it be that. And if I wanted to talk about the motion for v, it's going to be 1 in the x direction, negative 2 in the y direction. Right, so 1, 2, and that would be vector v. Okay, pretty straightforward for plotting. All right, and if I wanted to do u plus v, all right, so I'll move this a little bit. For u plus v, I could start at some given point, do 1, 2, 3, 1, 2, 3, 4, 5, all right? So there is vector u, okay? And then for vector v, right, going from head to tail, so over 1, 1, 2, right? So then there's vector v. And that result, sometimes called the resultant vector, right? That result is vector u plus v. Okay, and if I want to do u minus 2v, if I wanted to do u minus 2v, I could say, well, here, let me, be at some point, 1, 2, 3, 1, 2, 3, 4, 5. All right, so there is vector u. Right? Well, minus 2v would be going in the opposite direction of vector v. So instead of going right and then down, I'm going to go left, then up. All right, so that would be minus v, and then do it again because there's 2 of them, and that would be minus v as well. And the result, right, and if you prefer, you can always use a straight edge, right? The result to go starting at u, and then going negative 2v, that result would be that u minus 2v. Okay, so that's how our setup goes. All right, now if we wanted to work with component forms, this would be given by 3 times 3 comma 5 plus 4 times 1 comma negative 2. Okay, just setting up the components. And of course, 3 times 3, 3 times 5, plus 4 times 1, 4 times negative 2. Okay, and if I go through that, that gives me then 13, 9 plus 4, and 7, 15 plus negative 8, and that's going to be my 3u plus 4v. Okay, pretty straightforward. If I want the magnitude of u minus 2v, I need to be able to figure out the directionality of u minus 2v. I can either do that from plotting and seeing that, hey, I'm going to move over 1 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. right? That it's going to be to the right one and up by 9. But I could also have done it from working with this right up here. U, and then minus 2 times 1. And u minus 2 times negative 2. Either way, we'd get to the same piece. And so then the magnitude, and you can use single bars for absolute value or double bars. They do end up meaning different things in more advanced settings, but for now, just need to be familiar with the different ways you can write it. Okay, and Pythagorean theorem, right? 1 squared, 9 squared, that would be the square root of 82. That doesn't simplify further, right? That would be surd form. Okay. And if I wanted the directional angle of u plus v, also known as the argument of a vector, well, I need to be able to figure out what is u plus v. Once again, for u plus v, I could look 1, 2, 3, 4, 1, 2, 3, right? Or I could 3 plus 5 plus, right? Either direction. And if I wanted to think about, well, what's going to be the angle that I'm talking about? Well, let's look at a standard setting for angle and standard position, right? U plus V would be going in that direction, where I would have the angle we could label as theta, right? And we would know, of course, that the tangent of theta would be y over x. So theta would be the inverse tangent of 3 over 4. And using my calculator, I get that that's about 36.9 degrees. Okay. All of this is straight from what we did before in vectors and in learning trigonometry initially. Right? This is just saying that from standard position, if I go up 36.9 degrees, then that's the direction u plus v is going. Okay, so that's a little bit of vectors, working with plotting, vector addition, vector magnitudes, and directional angles. All right, I'm El Profe Lo. If you need help, as always, please reach out.